Which path does an individual electron take? Path 1 or path 2? Well, let's go through the scenarios. So if it took path 1, then that means it was a hard electron, and based on our previous experiments, we know that if it's a hard electron, its color statistics should be 50-50, but we find that that's not the case. Likewise, if the electron took path number 2, then it was a soft electron, and its color statistics should be 50-50, but we find that that's not the case either. Okay, so the electrons, they didn't take path 1, they didn't take path 2, so the other option is, let's say it somehow took both paths. We can test this though. We can stick a barrier on path 1 or stick a barrier on path 2, and we never get a half of an electron hitting the barrier. We always get a whole individual electron hitting the barrier. So there are never any half electrons that hit the barriers, so we can't say that it took both paths. Okay, so the only option left is to say it took neither path, but we can test this also. Let's say we put a barrier at path 1 and path 2 so that no electrons can get through, and sure enough we find that no electrons come out of the last color box, so we blocked all the electrons. So it didn't take neither path. Okay, at this point we've exhausted all of our options. We're saying that the electrons, they don't take path number 1, they don't take path number 2, they don't take both paths, and they don't take neither path. So what or where is the electron when it's going through this hardness box? Scientists had to come up with a new term to describe this type of movement, and they called it superposition. So superposition is a way to describe the movement of